Exercise here. So I think it's 2i. We're talking about second derivatives, and that's exactly what you think it might mean. Okay, so we have the function, we differentiate it. We're going to have f dash of x or dy on dx, and then we can differentiate it again. And we have f dash dash of x and d squared y on dx squared. And we stop there. I mean, you could keep going. You could keep applying the process. But as far as physical significance goes, we stop here in terms of the course. And so we're going to be talking about that today. We're going to be differentiating twice, and then in your next unit, we'll talk about the what that actually means. So all we're going to do is we're going to say, well, y is x to the power of a third, and then we're just going to differentiate that once. So dy on dx is going to be a third x to the power of negative 2/3. Okay, nx, n take 1. And then we'll do it again. So we've gone from dy on dx to d squared y on dx squared. This is the correct way to write it. Notice how the squared is in between the x and the y. So maybe it's flat or something. All right. So here we've got x squared take 3x on the square root of x. No, hang on, we haven't finished yet. 1 on 3 times minus 2 on 3 x to the power of minus 2/3 take 1 is going to be minus 5 on 3. And we'll leave it like that. We don't need to simplify it. So, okay, here, now you might be looking at that going, quotient rule. Let's do the quotient rule, and let's do the quotient rule. And you could, but you would have to do the quotient rule twice. In fact, there's a much faster way, and we should always be looking for the quickest way to do things. So yes, it would be acceptable for you to do the quotient rule. You would get full marks, but there's a way we can simplify this, and that is by splitting the denominator. So we can write this as x squared on top of x to the half, take 3x on top of x to the half, and now it simplifies nicely. We're going to have x to the 3 on 2, okay, 2 take a half, and here we're going to have 3x to the half. All right, so now we're just going to differentiate twice, term by term. So let's go through here. We're going to have f dash of x is 3 on 2 x to the power of a half, and then take 3 times a half, x to the power of minus a half. All right, we're just leaving the 3 hanging out the front here. And then ready to differentiate again, f dash dash of x. 3 on 2, half x to the minus half. Take 3 times half times minus half times x to the power of minus 3 on 2. Okay, and you are welcome to expand and sort of collect those things, but it just says find the second derivative. So, yep, always look for the simplest way to do it. You could apply the quotient rule there. Okay, let's move over to C, and we've got y equals cos of e of x. So it's cos of x, and we learnt yesterday that dy on dx is going to be minus e to the x sine of e to the x. Okay, so the rule, I'll just write the rule up so we can remember that. If we have cos of fx, it goes to minus f dash of x sine of fx. Okay, so that part's okay. But then we need to differentiate that again, and it's not so simple. We can't just go, what's the next step straight away? Here I've got minus e to the x times by sine of e to the x. All right, so we've got u times v. We have to use the product rule here. So u minus e to the x, u dash minus e to the x. V is sine of e to the x, which means v dash is going to be e to the x cos of e to the x. All right, and that's applying the rule for sine. Okay, sine of fx is f dash of x cos of fx. And e to the x, the derivative of that is just e to the x. And then we're ready to bring all that together. So d squared y on dx squared u dash v plus, here we're going to have, that's going to be take because that's negative, take e to the x times e to the x cos of e to the x. Now that's sine e to the x. Okay, something like this, e to the x times e to the x, that's e to the 2x, isn't it? So you could write it like that, or we could even factorize e to the x out the front. It's minus e to the x times sine of e to the x plus cos of e to the x plus e to the x cos of e to the x. Okay, so there's different ways of representing that. Excellent. Okay, let's move on to the last one when you guys are ready. And we've got f of x is ax squared plus bx plus c, and we're told all of this information. Now remember I said yesterday, all right, don't know how to solve it, just use the information that we've got. So the first part says f of 0 is 3. So let's use that piece of information. When x is 0, y is 3. So we're going to have a times 0 squared plus b times 0. We've already got the value of c, okay, just by putting the first piece of information in. Okay, in order to put the second piece of information in, we're going to need the derivative, aren't we? We need, it says find f dash of 2, I think it says. Yep, f dash of 2. So that means we need to find f dash of x. So up here, I'm just going to do both at the same time. That's going to be 2ax plus b. That's f dash of x. And then I'll find the second derivative straight away as well. The second derivative is going to be f dash dash of x, which is just going to be 2a. Okay, and then we're ready to use those last two pieces of information. Let's use the last one first. We've got f dash dash of x equals minus 4. And here we found f dash dash of x equals 2a. So we've got 2a equals minus 4, and a is negative 2. Okay. So we've recognised that's f dash dash of x, that's f dash dash of x, so therefore they're equal. We can solve for a, and then let's use that to solve up here. So we've got f dash of 2 is minus 5. So I'm putting 2 into the first derivative. So we're going to have f dash of 2 is minus 5. That's going to be 2 times a. Now we've already established a is minus 2, so let's put that in straight away. We've got 2 times minus 2 times x. The value of x we're talking about is 2, plus b is equal to minus 5. And we're just solving that for b. Here we're going to have minus 5 equals minus 8 plus b. And we'll have b equals 3. So therefore this quadratic is minus 2x squared plus 3x. Take 4 plus 3. Excellent. So let's get into second derivatives, and I've got some practice tests I'm going to hand out to y'all. And so I've got two practice tests, right? So what I've got for you, I've got the 2020 and the 2019 tests, and there's both the 2017 and 2018 tests on the Google Drive, so you can print them yourself, or maybe I can print them for you next lesson if you've done both ones already, sort of like get some more. So yeah, anyway, we'll be working on this today and revision Friday, but I will be away Friday. So let's get into it. 2i. Wonderful. Thank you very much, guys.